Welcome, everybody. So last week we talked about kind of one-dimensional motion and eventually got to a point where we had this set of equations written down. These are typically called the kinematics equations, and they describe the motion of an object that is undergoing constant acceleration. And we are going to explore today a little bit of what happens when we want to go from one-dimensional motion to two-dimensional motion. And you can see that I have put vector symbols on here to indicate the direction of these things, right? A is a vector, and it points in the x direction, for example. We can, of course, simplify our lives in one dimension and kind of just truncate down to a non-vector based equation where I only have to worry about whether something is positive or negative. When I do that, you can already see, as you've practiced with these equations on your homework, that there's a lot of different variables to keep track of here, right? There's the acceleration itself. There's the velocity, which you can have as a function of time. You can have a final velocity, and you can have an initial velocity. You can also have the same sort of thing with position, a position as a function of time, a final position, and an initial position, and of course, we have time in here as well. We have to keep track of all of these different quantities and how they are related to each other. Once we do that, however, you can start to see that if you know a couple of these quantities, maybe the acceleration and time, or the velocity at the start and the velocity at the end. Once you know two or three of these things, you can use these equations one by one to figure out what all of the other quantities are. That's kind of the essence of solving one-dimensional kinematics problems.